Welcome to all. In this video, we are going to study about Aldol condensation in organic chemistry. For this session contains definition of Aldol condensation, types of Aldol condensation, reaction involved in Aldol condensation, and then mechanism also. First part of the Aldol condensation is definition and types. Definition: Aldol condensation occur in aldehydes having alpha hydrogen with a dilute base to give beta hydroxyaldehydes called aldols. That means our product is containing aldehyde group as well as alcoholic group. This reaction is commonly known as aldol condensation. If that condensation reaction occurs between two different carbonyl compounds, then it is called as crashed aldol condensation. What do you mean by condensation reaction? Simply loss of simple molecule such as water or methanol. Condensation reaction. Condensation reaction means a reaction in which two or more molecules combine to form a large molecule with the loss of a small molecule such as water, ammonia or methanol. While this occurs in many reactions, the term is usually reserved for that reaction in which a new carbon-carbon bond is formed. That type of reaction is called as condensation reaction. Aldol condensation is possible only when the carbonyl compound containing at least one alpha hydrogen atom. What is alpha hydrogen atom? An alpha carbon is the first carbon that is joined to the functional group. In the case of aldehyde and ketones, a functional group is a carbonyl group. The functional group is responsible for the formation of alpha hydrogen. So, alpha carbon means first carbon that is joined to the functional group. The functional group is responsible for the formation of alpha hydrogen. Alpha hydrogen. The hydrogen present on the alpha carbon is the alpha hydrogen and it is slightly acidic in nature due to the carbonyl group and its resonance stabilization mechanism. Thus, alpha hydrogen and its acidic nature are responsible for several different reactions which we will study in this topic. Another one way of definition of aldol condensation is aldol condensation is a condensation reaction in organic chemistry in which an enol or an enolate ion react with a carbonyl compound to form a beta hydroxyaldehyde or beta hydroxyketone. That is aldol reaction. This aldol reaction followed by dehydration to give a conjugated enone. Aldol condensation plays a vital role in organic synthesis, creating a path to forming carbon-carbon bond. Aldol condensation. Here we are taking 2 moles of acetaldehyde. Acetaldehyde molecular formula CH3CHO. CHO is the functional group. Functional group attached carbon containing 3 hydrogen atom. Therefore, that compound is containing 3 alpha hydrogen atom. Acetaldehyde CH3CHO contains 3 alpha hydrogen atom. One of the hydrogen atom is removed by base. Here base is act as a catalyst. So that proton removed by the base to form carbon ion. That means acetaldehyde loss one proton to form CH2CHO. That CH2 group is carrying negative charge. That means CH2 minus CHO compound is formed. That is called as carbanion. Simply carbanion is formed. This is first step. Therefore, the carbanion is formed as a alpha hydrogen atom is removed as a proton by the base. Second step, this carbanion attack to the carbonyl carbon of another unionized aldehyde. First step product carbanion now going to attack to carbonyl carbon of another one aldehyde group. So automatically bond migration takes place to form alkoxide ion. So combined compound is formed. That alkoxide means that is a common representation for that product. So second step, the carbanion attack the carbonyl carbon of another unionized aldehyde to form an alkoxide ion. Now third step, that alkoxide ion is protonated by water H2O, H plus OH minus. That proton is attacked to alkoxide ion to form aldol. See that aldol, that is 3-hydroxybutanol containing OH group as well as CHO group. Therefore, that is aldol. Aldol means when a compound is containing aldehydic functional group as well as alcoholic functional group, that is called as aldol. IUPAC name of the product is 3-hydroxybutanol. Starting compound 2 moles of acetaldehyde. Step 4. The product aldol rapidly undergo dehydration on heating with acid to form alpha beta unsaturated aldehyde. See this equation. Alpha carbon loss one hydrogen, beta carbon loss OH group. Combined together, this compound is loss water molecule to form unsaturated aldehyde. Here 3-hydroxybutanol loss water molecule to form crotonaldehyde. That is a common name. IUPAC name is but-2-enol. Crotonaldehyde molecular formula CH3 single bond CH double bond CH single bond CHO. That is crotonaldehyde. Another one example of aldol condensation. Here we are taking 2 moles of acetone. Acetone molecular formula CH3COCH3. C double bond O is the functional group. That functional group linked by 2 alpha carbon atom. Each carbon atom containing 3 hydrogen atom. So totally 6 alpha hydrogen atom. But any one of the alpha hydrogen involved for the reaction. That any one of the alpha hydrogen atom is removed as a proton by the base to form carbanion. That means step 1 is the carbanion is formed as a alpha hydrogen atom is removed as a proton by the base. OH minus ion attack to CH3COCH3 to produce CH2 minus COCH3 plus H2O. Step 2. That carboanion attack to the carbonyl carbon of another one unionized acetone to form an alkoxide ion. In the first step product, CH2 minus COCH3 attack the carbonyl carbon of acetone. So bond migration takes place to produce alkoxide ion, that is O minus C CH3 twice CH2 CO CH3. Step 3. The alkoxide ion is immediately protonated by water to form aldol. Here, this aldol is containing ketonic group as well as alcoholic group. Product name is 4-hydroxy 4-methyl pentane 2-one. Carbonyl group as well as alcohol group is present. Therefore, that is aldol. This is aldol condensation reaction. That compound undergo dehydration on heating with acid to form unsaturated aldehyde. That is step 4. 4-hydroxy 4-methyl pentane 2-one involved for dehydration in the presence of acid. Heating for this compound to produce 4-methyl pent 4-ene 2-one, that is alpha beta unsaturated aldehyde. Therefore, if you are taking 2 moles of acetone that is involved for aldol condensation reaction in the presence of base, product is 4-hydroxy 4-methyl pentane 2-one. That product is involved for dehydration. Final product is 4-methyl pent 4-ene 2-one. Crushed aldol condensation. The condensation reaction between two different molecules of an aldehyde or ketone in a brotic solvent such as water or alcohol. That type of reaction is called as crushed aldol condensation reaction. Crushed aldol condensation reaction. Here we are taking acetaldehyde and acetone. Step 1. Acetaldehyde involved for the step 1 reaction to form carbonion. Acetaldehyde molecular formula CH3CHO. It will lose one alpha hydrogen atom by the base OH minus ion to form CH2CHO. That carbonion attack to carbonyl carbon of unionized acetone to form alkoxide. Carbonion attack to carbonyl carbon of acetone. Bond migration takes place to form one additional compound, that is alkoxide ion. That reaction takes place second step. In the third step, the alkoxide ion formed is protonated by water to form aldol. This aldol is containing carbonyl compound, that means ketonic group as well as alcoholic group. Name is 3-hydroxy 3-methyl butanol. that is aldol. This aldol involves for dehydration on heating with acid to form unsaturated aldehyde. 3-hydroxy 3-methyl butane 3-hydroxy 3-methyl butanol undergo dehydration on heating with acid to form 3-methyl 3-butanol, that is alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehyde means alpha carbon as well as beta carbon also remove some elements. Here alpha carbon loss hydrogen, beta carbon loss OH minus ion as a water molecule. Therefore, if you take acetaldehyde and acetone, that is involved for crushed aldol condensation, product is 3-hydroxy 3-methyl butanol, that is immediately involved for dehydration to form 3-methyl 3-butanol. Finally, conclusion. Aldol condensation is possible only when the carbonyl compounds containing at least one alpha hydrogen atom, suppose aldehyde or ketone, having no alpha hydrogen atom do not undergo aldol condensation reaction. So, aldol condensation is possible only when the carbonyl compound containing at least one alpha hydrogen atom. First step is a acid-base reaction. Hydroxide ion involved for the reaction to remove acidic alpha hydrogen to give the reactive enolate form. Second step is a nucleophilic addition reaction. Enolate attack the aldehyde at the electrophilic carbonyl carbon in the nucleophilic addition type process, giving an intermediate alkoxide. Third step, an acid-base reaction. The alkoxide debrotonate a water molecule creates hydroxide and the beta hydroxy aldehyde or aldol is obtained as a product. That aldol, otherwise known as beta hydroxy aldehyde or beta hydroxy acetone, involved for dehydration to form alpha beta unsaturated compound. That's all. Aldol condensation reaction. Students, practice it well. Thank you.